Hi, Year 11 IB. We're now starting the next topic on exponentials. So if you think about the functions you looked at so far, we've started off with quadratics, but of course linear functions from year 10 you've done. We've looked at notation, we've looked at composite functions, inverse functions, we've looked at rational functions. Now we want to look at exponential functions. So as the term exponential tells us, it's got something to do with the exponent. And in these functions, our variable is in the exponent. The opening problem that they give for you is looking at a freezer, and we're putting our peas into the freezer, and it's going to freeze up, and the temperature is determined after a certain number of minutes, T minutes, is given by this equation. So you can see here, capital T is our temperature, that's our function, whereas our variable in this case is T, little t. So just watch your notation. So now we can see our little t appears as the exponent in our equation, and that's why it's an exponential graph. You may have come across these before with exponential growth or exponential decay, and we're going to look at the graph in a lot more detail in the later sections of the chapter. But let's start by going over all our exponential rules and how to deal with exponents. What do exponents mean? Hopefully this is revision for you. So you could at this point pause the video and go through and then fill them all in and then turn it on to check your answer. I'll put a note for GDC here just to be able to make sure you can do these on your graphics calculator as well as in your own head. So pause it now and then come back and see how you've gone. All right, I've got the first few up for you. 81 should be easy. A to the n means we've got n lots of a being multiplied. And then the next ones are the trick ones that people usually got tricked up in years 8 and 9. Minus 5 cubed means the cube belongs to the 5 only, so it's minus 125. If I put it in brackets, it means I've got minus 5 times minus 5 times minus 5, which gives me the same answer, whereas this one previous was minus 5 times 5 times 5. The next one, if we go minus 5 to the 4th, that's like this previous example here. So our answer is going to be 5 lots of 125 is 625, and it'll be positive because the minuses all cancel. Whereas this one is the same as minus 5 times 5 times 5 times 5. I'm jumping to an answer. So it ends up as a negative 625. So the main thing to be watching is your negative sign part of what's to the power of 4? Is it in a bracket or not? So in this case, remember we're talking about an exponent and a base. Here we have a negative base. This is a negative base. Whereas in this one, our base is positive. This next example here, where we're looking at all right, so we're going to leave that one and come back to that in class time and work through that together. In 3B, we go through all these basic rules. So what I want us to do is go through these with number examples. So remember, a to the m times a to the m, a to the n, is a to the m plus n. So if I picked 5 to the 2 times 5 to the 3, the bases are the same. So we've got 5 to the 2 plus 3, which is 5 to the 5th, which is a big number. Quick calculator, work it out. Let me know when you've got an answer. Here, if we have a to the n times b to the n, our bases are not the same. So we can't put those together. Oh, I've just worked it out. 3125. Thank you, my assistant. All right, so this one here we can't put together. So if I have something like 2 cubed times 3 to the 5th, the bases are different. I can't put those together. If we take a power of a power, then you end up multiplying the indices. So our example here, let's stick with smaller numbers, so we do them in my head. If I do that and square it, then that's going to become 2 to the 6, and that is the same as 64. 2 cubed times 2 cubed. Here we have two different bases with the same power. They separate into a to the m, b to the m. So now if I have 2 cubed times 3 cubed, because the powers or exponents are the same, we can put those together. So this was different from this example, where the bases were not the same and the exponents were not the same. So this now can be 2 times 3, all to the power of 3, which is 6 to the power of 3, which is, what we've got, 36 times 3 is 116. Really close. Good job. All right, this one here, same story, a to the n times b to the n. The bases are different, but the exponent is the same. So this is a, b to the n. Okay, so that's like the previous example, just going back the other direction. That's going back that way. All right, hopefully that sounds good. If this is new to you, then you need to spend a bit of time really studying these so they become automatic. Now let's do the dividing. A to the n divided by a to the n is a to the n minus n. We obviously have a restriction here. A can't be a certain number. What do you know? What do you think that might be? And hopefully you've thought, well, we've got a in the denominator, which means we can't have a equal to 0, because we can't divide by 0. So let's pick a non-zero a. Let's go 2 to the 7th divided by 2 cubed. That's going to be 2 to the 7 minus 3 is 2 to the 4th, which is, we got 16. Next one here, when we've got a power involving a rational number, we go expand that so it takes the power of both of them, a to the n over b to the n, and of course b will not equal 0. Hopefully you've read my mind or you know that already. Let's pick an example. Let's go 3/4. What would you like to do with that? You want to cube it, stretch our brains. 4 4 is 16, so we've got 64, 27 over 64. So everything gets cubed. All right, let's do these powers of 0. That's the next one we want to go through. All right. Anything to the power of 0 is 1. All right. Why is that? If you remember our rule above, we just did the subtracting. So if I have a to the n over a to the n, then our rule says a to the n minus n, which equals a to the 1, not over the 0. But we can see that a to the n divided by a to the n is the same numerator and denominator. That must equal 1. So therefore, this equals 1. And that's going to be true for anything. So any power of 0 is going to be the same or is equal to 1. Even if I have 9x to the 0, it doesn't matter. All of that is to the power of 0, so it equals 1. But the next example, I've got 9 times x to the 0. The 0 is only operating on the x, right, not on the 9. So therefore, that's going to be 9 times 1 equals 9. So that's the tricky one that people slip up on. So just look carefully at what the power operates on. Next one here, we have a to the minus n. So that's another one you may have learnt. We could do a little proof of that. If we had a to the 0 over a to the n, which is what we turn that one into a to the 0, then our rule says subtract powers. So we have a to the 0 minus n equals a to the minus n. So that's one way of doing a little proof. So if I have 3 to the minus 2, that's the same as 1 over 3 squared. So negative indice means it's in the denominator. But what if we have a negative indice in the denominator? What do we do in that case? Let's pull this down as a bit of an example over here in a moment. So if we have 1 over a to the minus n, then that's the same as saying 1 over a to the n. If you want to really expand it out, it means we're dividing by 1 over a to the n. You then go back to your rules for fractions. That's the same as 1 times the reciprocal, gives a to the n. All right, so some of this is basically moving the indices around. Remember your rules and apply those carefully. And of course, we always need to think about domain restrictions. We can't have a equal to 0. So let's do this example now. I've got a couple here. Let's do that one over there. We'll do. Oh, no, we'll come over here. All right, so a to the 7th times a to the minus 4 divided by a to the minus 5. We know that this, if we do this part first, a to the 7th plus minus 4. All right, we can add those. Divide by a to the minus 5. We're going to have a cubed. If we're going to divide by a to the minus 5, remember, this is the same as 1 over a to the 5th. It's the same as multiplying by the reciprocal. So multiply by a to the 5th. So you basically change this to your multiply, and this becomes, that changes as well, from the denominator up to the numerator, becomes positive. But try not to just memorize rules, understand what you're doing. So we add exponents there at the end to get our a to the 5th. This one here, if we think of 3x to the minus 2, then x to the minus 2 means 1 over x squared. So it means we now have 3x squared is on the denominator. If we have y to the minus 3 in the denominator, that now comes up to the numerator. So there's our answer, 3y cubed all over x squared. All right, so a negative in the numerator goes to the denominator, a negative in the denominator goes up to the numerator. So let's look at some of the questions that are in the book. We'll run through just a few examples of those. In question 4, you need to write this as a single power of 2. So we're just going to do a and h. 2 times 2 to the a. If there's no indice, it's implied that it's a 1. So we now, same base, add exponents, a plus 1. We tend to write the code numeral and have the constant at the end. It's a polite and nice way of writing it. It's not wrong to write the other way. It's just a nice way of writing. It's a more elegant solution. And let's do h for 2 to the 1 minus n. Now, with what powers of 2? Let's turn the numerator into a power of 2. Over 2 to the 1 minus n. If, for the part in the denominator, we now need to subtract indices. So that means we've got 2 to the 2 minus, use your brackets to remind you that everything has to be subtracted. So we get 2 to the, what 2 minus 1 is 1, minus n makes plus n. So you can write it like that, or you can do the swap around with 2 to the n plus 1. Both answers are acceptable. In this next example, did I do it all? Just check the bottom. Yes. All right. Writing without negative indices. So if you look at F, we don't want any negative indices. So this was a bit like our previous example. B to the -1, C to the -2. Then the B -1 in the numerator goes down to the denominator. And C in the denominator comes up to the numerator as a +2. So that one's nice and easy. In the next lot of examples, or the next lot of questions, is where we have to write these as in non-fractional form. So we just want to use indices and not have it written as a fraction. So this example here, we want 1 over 2 to the 1 minus n. We now want negative to show that it was in the denominator. So we end up with 2 to the plus n minus 1. So I've just distributed that and put the n part first. All right. So I think that will do. I'd like to see you guys have a go at the other ones there. So we'll leave that for you. So I think that will do for today. Don't forget to make sure your notes are done well for this, and we'll look at that other example in class. Thanks. Bye for now.